when we talk about common angles, we mean the 4 angles that make up the positive and negative x and y axes, and 3 of the first quadrant angles. So starting with the smallest of those, our angle theta would be 0, not pi over 2, 0, then pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2. And then 2 pi would be the same as 0. Now there's a table in the lessons that has these values in radian measure, like this with pi's, and with degrees. And it has sines and cosines. So if I wanted to find, say, the tangent of pi over 3, what I would have to do is go to that table, find the sine of pi over 3, divide it by the cosine of pi over 3, and that would give me a value for tangent. Now, when I think of these, I think of sine first. I've memorized sine first. The 0 value for sine is 0. Pi over 2, the value for sine is 1 because I'm going around the circle. At pi, it's 0, and at 3 pi over 2, it's negative 1. So that's my value for sine. So it's the ones in the middle here, pi over 6, pi over 4, pi over 3. These are just first quadrant angles. But you know that we go all the way around a circle, so there are more angles than just the first quadrant. But these are things that you really should kind of have a reference for in your brain as to the sines and cosines of these 3 angles. The way I remember them is, as I do this, I think of these 3, pi over 6 is the smallest. Sine of pi over 6 is a half. Sine of pi over 4 is a half times the square root of 2. Sine of pi over 3 is a half times the square root of 3. Now, we can, some of the stuff that you'll look at in a little bit, you'll see how pi over 6 and pi over 3 are related. This is a 30-degree angle at a 60-degree angle, and how pi over 4 is a special one of itself. But these are things that you need to memorize. Now, if I want to find the sine of pi over 3, I'll look up here, and the sine of pi over 3 is the square root of 3 over 2. Turns out if you look in the table, the cosine is a half. So you can think, we've done this before, invert the denominator, multiply. My tangent of pi over 3 is the square root of 3. And so this table just gives you a way to find what we call common angles. Now I mentioned that we've got these common angles, but they don't just count for everything. We also need angles in other quadrants. But if we think in terms of the pi's, the radian measure, instead of degree measure, it's easy to kind of figure out where we are in the different quadrants. So let's look at angles in other quadrants. And first I want to talk about just the signs, the plus and minus signs. Now, if I have an angle on my unit circle, there's a point P. Point P is xy. But we saw that x is the cosine of the angle, and y is the sine of the angle. So if I'm trying to determine what the sine, SIG and sine of an angle is in the second quadrant, all I have to do is think about what's x and what's y over here. So if I am in quadrant 2, x, this is the x-axis, x is negative, so that means cosine theta is negative, because x goes with cosine. The y value there, the y is positive. So my sine of theta is positive. So you already know the plus and minus signs that go with x's and y's, so just use those to figure out when sine or cosine are positive. And then because we know that the other trig functions are in terms of sine and cosine, you can always determine what you're looking for. For example, suppose I have a cosecant of theta in quadrant 3. And I want to know what the sine is. Well, here's the third quadrant, 1, 2, 3, down here somewhere. Cosecant is 1 over sine theta. You know, you have to remember all of this stuff. The sine in the third quadrant, what's y down here? Y is less than 0. Okay. Y is less than 0. Sine is less than 0, so this is going to be 1 over some negative number, which means cosecant in quadrant 3 is negative. Because I can think of it in terms of sine and y. Okay. How about cotangent in quadrant 4? Alrighty, over here now, I'm in quadrant 4. Cotangent. Cotangent is cosine theta over sine theta. So that's like x over y. In the fourth quadrant, x, positive. So I have a positive number here, but y is negative in the fourth quadrant. Positive over a negative is a negative. So cotangent of theta in the fourth quadrant has a negative value. So we can always use these. Well, I mentioned angles in other quadrants. How about which quadrant has sine of theta less than 0 and cosine of theta greater than 0? Same idea. Sine is y. Y is negative. X is positive. Same thing we just did. That is the fourth quadrant. So you sometimes think questions could be written in different ways. Okay. Take that picture away. Let's look at the angle 11 pi over 6. Well, it's not pi over 6. It's definitely bigger than that. So where is it? How can I find sine, cotangent, and the other trig functions? 11 pi over 6, a couple ways to think about it. I always think about it in terms of pi and 2 pi. So if I'm looking at pi, or 2 pi, 11 pi over 6, 11 sixths is 1 5/6. Okay, it's greater than 1 pi, it's less than 2 pi. How far away is it? It's just 1/6 away from 2 pi. 2 pi is 12/6. It's over here. 2 pi minus 11 pi over 6. I can take the 2 pi, make that 12 pi over 6. Gives me a pi over 6. Oh, it is a pi over 6. Well, sure it is. Look, there's a 6 on the bottom. If you use radian measure, the denominator, as long as you're in lowest terms, tells you the angle you want to use. And these up here are what we call reference angles. So, if pi over 6 is my reference angle for 11 pi over 6, I started here and I went all the way around here, but I'm in the fourth quadrant. So, I used my pi over 6 values, but x is positive, cosine is positive, y is negative, sine is negative. So I find the sine of pi over 6, which is 1/2, which tells me that the sine of 11 pi over 6 is negative 1/2. My cosine of pi over 6 is not up there, but you will see that it is square root of 3 over 2. And that is also the same value, because cosine is positive in this quadrant, of 11 pi over 6. So this gives me my sine and cosine of an angle in the fourth quadrant, but I just use the angle that's in the first quadrant. I use the reference angle. Look at another one. Let's look at negative 3 pi over 4. And let's just find the sine of this. Okay, I'm going to use reference angles because this is not a common angle. Okay, common angles. So, negative 3 pi over 4, where does that get me? Let's see. 3/4. Oh, it's 3/4 of pi, but negative. So 3/4 means I'm going negative, but I don't go all the way to pi. I go 3/4 of the way. So I'll stop about here, or maybe a little bit lower. So this angle is negative. So I go clockwise from my positive x-axis. Gets me in quadrant 2. And since this says 3 pi over 4, I use pi over 4. Sine of pi over 4 is square root of 2 over 2, or sometimes 1 over the square root of 2. You can use either way. In quadrant 3, sine of theta, or y, is negative. So, my sine of negative 3 pi over 4 is a negative of whatever the sine of pi over 4 is. Okay. Cosine over here, because of x, would also be negative. Let's do one more of these. Suppose my angle theta is negative 9 pi over 4. And this time, let's find the secant of that. Since it's a pi over 4, it's got to be related to pi over 4. 9 pi over 4. Okay, where's this going to get me? All right. This is bigger than 2. 9/4 is bigger than 2. That's like, 2 1/4? So, and since it's negative, I go backwards. So I go all the way around to 2 pi, and then I go another 4th, which would put me back here. So this angle's in the fourth quadrant. Secant is 1 over cosine. So if I find the cosine of pi over 4, which is the same as the sine of pi over 4, I think this time I'm going to write it as 1 over square root of 2. And it is positive, according to the x is positive in the fourth quadrant. So I have the secant of negative 9 pi over 4 is positive, and it's the reciprocal of cosine, so it is a positive 1. Wait a minute. Cosine is 1 over. I almost left that out. I forgot to put the 1 over down. The cosine of pi over 4 is 1 over root 2, but I have 1 over that. So 1 over 1 over square root of 2 is square root of 2. And it is positive because x is positive. Again, practice the ones in the lesson because the examples and the topic discussion is good with pictures. Show you a lot more examples of these so you just get accustomed to seeing all these different combinations of things.